Hey guys, today I'm going to teach you all about rational numbers. This is an intro to rational numbers, so we're just going to start with the very basics. We'll start by classifying rational numbers, and then we'll start doing some math operations. So by the end of this lesson, you should be able to classify, add, and subtract rational numbers. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. Let's get started with an example that is not math, and it's going to make sense to you later because it will relate to the math we're about to talk about. But let's go ahead and get started with something that's not math at all. This is my dog Sawyer. He is my love of my life. I love him, my little baby. So we're not going to classify numbers right now. We're going to classify animals. We're going to classify my dog. So this is the real animal system. So scientists, mathematicians, and just regular people, we like to classify things. That means specify it, name it. So let's just start out. The big category of what my dog is animal. He is an animal. That's the big box. So what are some other animals? Well, we have frogs, we have lizards, we have cats, and we have dogs. So different types of animals is the first category that he belongs to. More specifically, though, we know he is a dog. So he's an animal, but he's also a dog. So dog would be this category. He could be an outside dog, an inside dog. He's a dog. So Sawyer is both an animal and he's a dog. A lizard is just an animal, but a lizard is not a dog. So a lizard doesn't go in the dog box. Let's get a little more specific. So looking at this box, we'll look at what kind of dog he is or his breed. Can you guess what kind of dog he is? He is a border collie. So in this box, there's different types of dogs. He is a border collie. Um, Golden retrievers could go in this breed, but golden retrievers aren't my dog. So in this more specific box, this last box, this is the most specific one. This is his name. This is Sawyer. So Sawyer, we can classify as a border collie, which is a dog, which is an animal. So he's not a frog, he's a dog. So if there was a frog classification, the frog would just be outside in this big box. Your dog might be a golden retriever. So your dog might be an animal who's a dog, who's a golden retriever, but your dog's not Sawyer. So your dog that's a golden retriever would just be up in this box, and this box. So this is just a way to classify animals. And in just a minute, you'll see how this relates to numbers. So let's go ahead and look at this page right here. You should have this in front of you with a pen or a pencil, and you should fill in as you go. If you need a second to catch up, pause the video and catch up. So this is an intro to rational numbers. The number system classifies numbers based on their type and characteristics. So the number system does the same thing that we just did with the animal system. It classifies based on their type and characteristic. So the first type of number is a whole number. You probably know that whole numbers are just numbers that you can count, positive counting numbers, starting with zero. So we include zero in that. So 0, 1, 2, 3, all the way up to infinity. So 0 is an example, 4 is an example. Pause, think of two more examples. Press play whenever you've got two more examples. Okay, you should have thought about it, and I chose 7 and 14. Your examples could be any whole number between 0 and infinity. So the next type of number is a natural number. This is the set of positive integers. So we'll talk about what integers are in just a second, but basically, natural numbers are your counting numbers. So another word for natural numbers are your counting numbers. So this is everything that we just listed as whole numbers except for 0. We don't count 0 in natural numbers. Natural numbers are numbers you can count naturally, like on your hands or your feet. So 1, 2, 3, 4. The way I remember that is you can have a whole lot of nothing. So you could have 0 for the whole number, but you can't count 0 on your fingers. So 0 is not a natural number. The next set of numbers is integers. This is the set of whole numbers and their opposites. So that would mean all of your whole numbers, like 0, 4, and their opposites. So 0 is also an integer, but so is -4. So is 4, so is 7, and so is -7. It's every number that is a whole number that is negative and positive. So it's your positive and negative whole numbers. So pause, think of a positive and a negative whole number, and then press play when you know. Okay, so I thought of -18, that just came to mind, and then 3. So any whole number, positive or negative, is called an integer. Now the last type of number is called a rational number. Rational number is the biggest category because whole numbers are in it, natural numbers are in it, and integers are in it. So rational numbers are all of the numbers that we just listed plus fractions and decimals. So numbers that can be written as fractions, decimals, and repeating decimals. So you probably are seeing an unfamiliar word here. You might not know what terminating means. It just means ending. So some examples could be like 1.5 is a decimal that comes to an end. So that's a rational number. So is 4 and 7 and all those numbers we just saw up top. So are the negative numbers. But so are fractions. 3/4 is a rational number. 3/4 is a rational number, but 3/4 is not an integer because it's not a whole number. So that rational numbers is all those other numbers and fractions and decimals. So now we're going to look at some fractions and just recognize if they're terminating or repeating. So again, one more time, terminating just means ending. So think about the Terminator. I will end you. That's what Arnold Schwarzenegger in the Terminator, if you've ever seen it. That's how I remember it. If it ends, it's terminating. If it repeats, then it keeps going and it repeats itself, obviously. So the way to figure this out is to pick up your calculator. You can use your phone or that Desmos website, and you just want to recognize that this line means divide. So 5 divided by 6. You would type in your calculator. 5 divided by 6 gives me 0.833333. It keeps repeating. So in math, we're lazy and we don't want to keep writing 3's out. So we put a little hat over the number that's repeating. So that's your first time you might have been seeing that, but that is the way that we represent repeating decimals. So this is a repeating decimal. 5/6 is the same thing as 0.833333, and that is a repeating decimal. So this is a rational number. The next one is 2/11. You can use your calculator. 2 divided by 11 is 0.18. 18. The 1/8 repeats. Since the 1 and the 8 repeat, you put a little line over the 1 and the 8. So it's a little hat that tells you that you're going to put 0.18 repeating forever. This is another type of repeating decimal. So go ahead and try the next one by yourself and then press play when you think you have it. So you have 17/20. That line means divide, and you're going to recognize that 17/20 is the same thing as 0.85, but there's nothing after the 5. There's just zeros. This is a terminating decimal. It comes to an end. So the next section says label the different parts of the number system diagram below. So if you remember, this diagram is what we looked at for my dog Sawyer and classifying him. So we're going to look at the same thing with numbers. So whole numbers is the smallest category. Actually, natural numbers is even smaller than whole numbers, but we'll talk about that in a second. So whole numbers is the smallest category. So some examples of whole numbers are, remember, 0, 1, 2, and so on. 1, 2, 3, 4. It's all the positive whole numbers. The next category is integers. So remember, integers are the same thing as whole numbers, like 0, 1, 2, but they're also negative numbers, like -7, -11. So to make the connection back to Sawyer, dogs are animals, but not all animals are dogs. So -7 is an integer, but -7 is not a whole number. 2 is a whole number, and 2 is also an integer. So let's zoom out a little bit more, and the next big category that includes all these numbers, just like an umbrella, is rational numbers. So rational numbers are all the numbers that we've just listed and fractions. So all the numbers we just listed, like 0, 1, 2, -7, -11, but also 2/3, 5/6 that we just saw, 17/20. All the fractions and decimals that you know are rational numbers. All of the integers and whole numbers are rational numbers. So basically, every number that you've seen in your math life so far is called a rational number. One way to also think about rational numbers is that it has the word ratio in it. A ratio, member, is a fraction. So ratios are rational numbers. So this little check-up question says, is it possible for a number to be both a whole number and an integer? Why or why not? So go ahead and think of a whole number. I'll think of number 7, and I want you to tell me if that whole number 7, is it possible for it to be a whole number and an integer? Go ahead and try yourself, and then press play whenever you're ready to check. Okay, so you should have thought about that one and realized, yeah, 7 is a whole number, and it's an integer. It's in that integer box, and it's in the whole number box. So 7 is both an integer and a whole number. So now I want to look at the process for adding and subtracting positive fractions and decimals. So we're just going to review adding and subtracting rational numbers. This is something you might have learned in 4th grade, 5th grade, and practice more in 6th grade. So we're going to look at adding first. So let's just look at this box, adding fractions. So the first step when you add fractions is to find a common denominator. Remember, a denominator is the bottom part of a fraction. So you might want to write that down. In these examples, 8 and 2 are the denominators. It's the bottom part of the fraction. So the next step whenever you are adding fractions is to rename all the fractions. So you find the common denominator, you rename your fractions, and then you add only the numerator. Remember, the numerator is the top part of the fraction. So in these examples right now, it's 7 and 1. And then you'll want to, the last step, keep the denominator the same. So those are your steps to solve the problem, but let's look at it with an example. So 7/8 plus 1 1/2. I'm going to go to a separate page to do this math. You might want to do this on a separate piece of paper or your little whiteboard. So step 1 was to find a common denominator. So we're going to find the least common multiple between 8 and 2. That would be 8. 8 goes into 8 and 2 goes into 8. So I'm going to rewrite this as 8 over 8 plus something over 8. I'll leave the 1 over here by the side. So now I need to rename my fractions. So 7/8 hasn't changed. But the way I got from 2 to 8 was to multiply by 4. So if I do it to the bottom of the fraction, I have to do it to the top. So you should realize 1/2 is the same thing as 4/8. Now that I have a common denominator, I've rewritten my fractions. All I do is add the numerators. That means the top part of the fraction. So I'm going to add 4 plus 7. 4 plus 7 is 11. I'm going to keep the denominator the same. And remember, I have this whole number 1 off to the side. So right now I have 1 11/8. You might realize from back in your 6th grade math that this is an improper fraction because the numerator is greater than the denominator. And since it's not fully simplified until we have made this a proper fraction or a correctly written mixed number, we are not done. So now we have to think, how many times does 11 or 8 go into 11? It goes in 1 time, and then there's 3 left over. So we add a 1 to the whole number 1. So we now have 2 3/8. So that was just one process to add your fractions. There's a few different ways you could have done that problem. Do whatever works for you. That's just one way. And these are the steps to do that. The next thing we want to look at is how to add decimals. So if we can add fractions, we can also add decimals. So the first thing we will do whenever we add decimals is to rewrite the problem vertically. In basketball, your vertical is how high you can jump. That's up and down. It's top to bottom. So vertical is up and down like this. The next step is to line up all the decimals and fill in placeholders. Remember, that's just your zeros. Then you add the like place values, so the places that are in the same spot. So I'm going to take this problem on a separate piece of paper or on your mini whiteboard, and we're going to do that together. If you remember how to do this or you want to try it by yourself, you might want to go ahead and try it, and then we can press play whenever you're ready to check. So the problem was 268.97 plus 38.659 thousandths. So then you look at your instructions. It says rewrite the problem vertically. So we're going to write this on top of each other. So we're going to write by lining up the decimals. So we'll keep this in the first place, and then we'll move this 38 over. So 38 is here. The tens place is lined up with the tens place. 1 is lined up with the ones place. And then we have a 0.659. So now that I've rewritten it, I'm going to go ahead and move this away. And I'm going to add my placeholders. So the next step is to add placeholders or zeros. Then I'm going to draw my line, and I'm going to add straight up and down. 9 plus 0 is 9. 7 plus 5 is 12. So I bring down the ones digit and carry the 1 because that is the tens digit. So then I can continue adding. 9 plus 1 is 10, plus 6 is 16. Carry the 1. Bring down the decimal before you move any further. The decimal should always be lined up. 8 plus 8 is 16, plus 1 is 17. 6 plus 1 is 7, plus 3 is 10. Carry the ones digit. 2 plus 1 is 3. So your final answer should be 307, and 629 thousandths. So that was a review of adding fractions and decimals. Now you can call them rational numbers. Remember, fractions and decimals are a type of rational numbers, and that should be a review. If you had trouble with any of that, let me know and we can get you some extra practice. So now we're going to talk about subtraction. So the subtraction seems a little scarier, but it's the exact same process. We'll start with subtracting fractions. You find a common denominator. It's the same way you would if you were adding fractions. You find a common denominator. Then you rename all your fractions. So make sure that they are equivalent fractions to what you had to start with. So the next step when you want to subtract fractions is to subtract the numerators only. So you're only subtracting the top part of the fraction. And then just like adding fractions, you want to keep the denominator the same. So I'm going to show you a different way to subtract these. So the first thing we might want to do is to make sure that this mixed number is written as an improper fraction. So I know we don't usually write as improper fractions. We know that we need them to be mixed numbers to be solely simplified. But sometimes when we're adding or subtracting, it's helpful for them to be written as improper fractions. So there's a strategy you might have learned. You multiply these two numbers, so 2 times 4, and then you add the number that's on the top. So 2 times 4 is 8, plus 3 is 11. So 11/4 is an equivalent fraction for 2 3/4. They're the same thing. So this is just a different way to solve this out. You might have your own way to solve this, but that might be my first step. Then we'll look at the method for solving this. It says find a common denominator. So we want them to have matching pants or matching shoes. That's one way I like to think about it. You can't do anything with them until they match on the bottom. So we'll go ahead and make sure that we find the least common multiple between 3 and 4. So it might help for you to list them out, 3, 6, 9, 12, 15. Then we'll look at 4, 4, 8, 12, 16. But I know I can stop because I found that 12 is the least common multiple between 4 and 3. So I'm going to rewrite both my fractions with a denominator of 12. So I'll start by rewriting 11/4. I know it's going to be out of 12, so I have to think, how did I get from 4 to 12? I multiplied by 3. So you multiply by 3 on the bottom, you have to multiply by 3 on the top. So 3 times 11 is 33. So 33/12 is an equivalent fraction, or it's the same fraction as 11/4. And the way that I got that, like I just said, was I know that I needed 12 as my least common multiple for the denominator. So I needed to get from 4 to 12. So if I got from 4 to 12 by multiplying by 3, I'd have to do the same to the top. 11 times 3 is 33. So we'll do the same thing for 2/3. I need a 12 on the bottom. And what I want you to do is to pause the video, think to yourself, what times 3 gives me 12? And then whatever that is, do the same to the top. So you should have paused the video and thought about it and realized 3 times 4 is 12. If I multiplied by 4 to get 12 on the bottom, I'm going to do the same thing to the top. In a fraction, whatever you do to the bottom, you have to do to the top. So 3 times 4 is 12. 2 times 4 is 8. So now I'm looking at 8/12 is my equivalent fraction for 2/3. So the next step that was listed was to just subtract the numerators. Remember, the numerator is just the top part of the fraction. So I'm just going to subtract 33 minus 8. 33 minus 8 is 25. And then 12 minus 12 is 0, right? No, you don't subtract the denominators. Do not subtract the denominators. That's the biggest mistake that I see. So keep the denominator the same. That's the fourth step listed on your instructions we just went over. So 25/12 is your answer. It would be correct on some places, but for me, I need you to simplify it. So we made it an improper fraction at the beginning, but now we're going to take it back and make it proper again. So the way to do that is to think, how many times does 12 go into 25 evenly? 12 times 1 is 12. 12 times 2 is 24. So 12 goes into 25 2 times evenly with 1 left over, and then out of the 12 that we started with. So we'll practice that as we go along, but that is how you can subtract those two numbers. So now we're going to look at the last one we need to review, which is subtracting decimals. So the steps for subtracting decimals are going to be very similar to adding decimals. We'll start by rewriting the problem vertically. The next step will be to line up all the decimals and fill in placeholders. Then we will subtract like place values. So I'm going to go to a different piece of paper or a different sheet, or I'm going to erase my little whiteboard and I'm going to rewrite this problem. I want you to try it by yourself and then come back to check. So the problem is written horizontally, and I know my first step is to rewrite the problem vertically. So I know that since this is the bigger number, I'm going to leave that one on the top, and I'm going to subtract 96 from the spots that the 7 and the 0 are in. That's the tens place and the ones place. I'm going to line up my decimals, and then I know that it's 0.38. So I'm going to go ahead and get rid of this over here, and I'm going to go ahead and subtract like normal. Already, when you subtract, you should see that you're subtracting the 5 and the 8. However, you can't take 8 from 5, so you need to borrow from the place next to it. So I take away that 4 and take away 1, so I'm back at 3, and I add that 1 here. So now I'm doing 15 minus 8, which is 7. I look next door. 3 minus 3 is 0. Keep my decimal lined up. 0 minus 6 I cannot do, so I go ahead and look next door and borrow. So that is now from 7 to 6, and I bring the 1 over. So 10 minus 6 I can do, that's 4. 6 minus 9 I cannot do, so I borrow from next door, and I make it a 1 here. 16 minus 9 is 7, and then 7 minus 0, because remember there's a placeholder of 0 here, is 7. So my final answer is 774.07. So that was a quick review of how to add and subtract rational numbers like fractions and decimals. Now what you have below that is some independent practice and a summary. So this independent practice says practice adding and subtracting the fractions and decimals below. This is for you to try by yourself. So I want you to do these 6 problems all by yourself, and then we will go over them together live. Where it says summarize the day's lesson, that's wherever you can put down some just jotted notes that you might have learned. Maybe you learned how to turn a mixed number to an improper fraction, and you might want to write that little method down. You didn't know where to put it before. This would be your space. All right, guys, that's it. If you made it to the end of this video, please put your favorite emoji in the comments. Today, we went over an intro to rational numbers. This was just the basics. We started out by classifying my dog, and we realized that classifying animals was a lot like classifying numbers. So now you should be able to classify rational numbers, add and subtract rational numbers like fractions and decimals. And now what I want you to do is go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye!